Now that we know what a one-to-one function is and roughly what an inverse function is, when we graph these two on the same graph, there is a special relationship, and it's that both the one-to-one function and its inverse function will be symmetric with respect to the line y equals x. Now, this should look familiar. This was part of our key graphs. This is considered the identity function. And in this diagram here, in this graph, that is this black line that's going through perfectly diagonally going through the origin. And so you can see if you fold your paper over that line here, everything would land on the opposite side of that line of symmetry. Now, example 4, 5, and 6 all ask these 5 things. But in example 4, we have right here a linear function. So we're going to graph its inverse a little bit differently on example 4 than we do on examples 5 and 6. And you'll kind of see what I mean. But on this one, the first thing that we're going to do is simply graph this. Now, because this is a line, we should know how to graph this function. This is my y equals mx plus b. So this 3 represents my slope. And so my slope here is 3. Now, because I'm going to be graphing this, I need a rise over run. And so we'll turn this into 3 over 1. And then this 4 right here is my b, and that represents my y-intercept. So my y-intercept is at 0, 4. So when I go to graph, we're going to start at that y-intercept and then use your slope to plot your points. We'll go up 1, 2, 3. That's my rise, and then run 1 positively. So since it's positive over positive, I'm going up 3 into the right 1. Now, technically, when you have a line, all you need to be able to graph that line are 2 ordered pairs. However, I want this to be very accurate, and so I'm going to use my rise over run for the entire graph. So I'm going to go up 1, 2, 3 over 1. And now I'm going to go in the opposite direction. So 3 over 1 is the same as -3 over -1, because negative over negative is still positive. So we'll go down 1, 2, 3, and then to the left 1. I'm going to do that all the way down. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So there is my graph. And we're going to put both this one-to-one function, well, I guess we don't know if it's one-to-one yet, but both this and its inverse on the same graph. So I am going to label this as f. This is my function. Okay, so that is part A. For part B, it wants to know, is this a one-to-one function? Well, we determine that by using that horizontal line test. And anywhere I put a horizontal line, it only intersects once. So yes, I'm going to put in parentheses because it passes the HLT. So part C, does my function have an inverse? Well, these two go together. If it is yes, one-to-one, then it is yes, it has an inverse. I'm going to do yes with an arrow up. Because it is one-to-one, it has an inverse. So now part D, we need to, if it does, meaning if it does have an inverse, graph the inverse on the same axis, meaning the same graph. So here's what I'm going to do. I am going to list my ordered pairs of this function here. So this one down here is -4, -8. Then we've got -3, -5. We have -2, -2. We have -1, 1. 0, 4. 1, 7. And I'm going to cram in here a 2, 10. So there are my 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 7 ordered pairs that I have on my graph. I'm going to change colors to represent my inverse. And now for my inverse function, I'm going to switch my x and y. So this 4 through 2 was on my x. Now it's going to be on my y. And then my y column will now become my x column. Okay, and now I'm going to plot these 7 ordered pairs and connect them on my graph. So there is my inverse function. Pause that if you need some more time. And again, because I have 2 different graphs on this one graph, I need to label. So I've already labeled this one as my function. I'm going to label this one as my inverse, so f to the -1. Now, if you are a visual person like I am also going to draw in my line of symmetry, this y equals x line. And so I'm going to go from corner to corner through the origin, and I'm going to put this in as a dashed line because it's not really part of the graph. It's just kind of here for visual purposes. This is my line of y equals x. And so now that we've drawn that in, you can see how it is symmetric. If you were to take your paper and fold it over, everything would land on top. Or you could look at it as this left side mirrors this right side right here. Now, a big part of this lesson is finding the inverse function. Okay, and so what I mean by finding the inverse function is we have drawn the inverse function, but what is the name of this inverse function? And so to do that, we're going to do this work right here, and this is our steps to finding the inverse function. So it says, continued from above, example 4e, find the inverse of f of x equals 3x plus 4, which was my original function here. And so to do this, we have 4 steps. The first thing I want to do is replace my f of x with y. So instead of f of x equals, I'm going to do y equals 3x plus 4. Step 2 is interchange your x and y. So now where I see a y, it becomes an x. And where I see an x, it's going to become a y. Step 3, we need to solve for x. No, that's not right. Let's solve for y. Sorry. Solve for y. So I need to get this y by itself. So to solve for this y, first thing I need to do is subtract this 4 over. And so we have x minus 4 equals 3y. And now we need to divide by 3. Now what gets divided by 3 over here? And that's everything. So the x will get divided by 3 and the 4 or -4 will get divided by 3. So this is the same as 1x. So 1 over 3 becomes 1/3 x. And then I can't do anything with -4 over 3. So -4/3. And that equals y. Now, do not stop right here. If this is a test question, this is partial credit because we still have another step, and I often will get this is my answer. So step 4 is now to replace y with your inverse notation. So the inverse of x. So my final answer here for part E is the inverse function of x equals 1/3 x minus 4/3. And we can look at that on our graph. 4/3 is 1 1/3. You can see that's roughly about 1 1/3. And then my slope is 1/3. So from each of these points, we are rising 1 and running 3, rising 1, running 3, that entire way right there. So we now have not just graphed the inverse function by switching the x and y coordinates, but now I even know the name of that inverse function.